Hi everyone, nice to see you all. This is my second video, and as promised, if I was going to make another video, I was going to show you my plant. Here's one of them. This is called Slothy McSloth, and he's got string of pearls hair, which I've been growing for like 3 years. Okay, so today what I'm going to show you is another method for adding and subtracting fractions, particularly ones with mixed numbers. So this is optional. Like if you like this way, you can use it. But if you find it confusing, use the other way. Um, it's really useful for really big numbers when we're adding two mixed numbers that are really big together. However, yeah, this is if you like it, use it. If you don't, use the other way. So you can use either way to add and subtract fractions. So at the top of the page, I've just given you some instructions, steps when you're adding, and I should write subtracting as well. You can exchange the word adding for subtracting in my instructions. So so when you look at adding two mixed numbers together, add or subtract the whole number parts, then you add or subtract the fraction parts. The denominators are different. We need to write them as equivalent fractions with the lowest common denominator, and then if need, simplify the answer. So I was going to do a couple of examples to show you how to do this, and then you can do some practice. So the first one, it says, simplify the following fractions using the second method. So we've got 3 2/3 plus 2 2/3. So remember, with a mixed number, you've got the whole number part and then you've got the fraction part. So it's the first thing you need to know is whether the denominators of my two mixed numbers are the same. So if they're the same, sweet, happy days, because it's pretty straightforward. What we do is we take the two whole numbers and add them together. So 3 plus 2. And then we add on our two fractions. So 2/3 and 2/3. So we add the whole numbers together and we add the fraction part together. So 3 plus 2 is 5. 2/3 plus 2/3 makes 4/3. And then if it's an improper fraction, you can convert that to to a mixed number. So 4/3 becomes 1 1/3. And then you can see I can add 5 plus 1/3, which makes 6 1/3. So it's a really good shortcut to do when it's nice and straightforward. You can still do it though if the denominators are different. So here we've got 2 5/6 plus 3 3/4. Check in this case, like you could see the denominators are different, but let's just start by writing the whole numbers and the fractions together. So we can go 2 plus 3. And I just put in a bracket just to show you that I put the whole numbers together and the fractions together. Plus 5/6 plus 3/4. So my two fraction parts of my mixed numbers together. So I can add my 2 plus 3 together. That's fine. So that's 5. 5, 6 3/4. What I need to do is write it with the lowest common denominator. So like we've been doing, write out your multiples if you're not quick with it. So multiples of 4, we've got 4, 8, 12, 16. Oops. And then multiples of 6, we've got 6, 12, and I can already see that 12 is going to be my lowest common denominator. So rewrite your two fractions with the lowest common denominator. So 12 plus 12. Go back and examine what's happened to your fractions to find the equivalent. So 5, 6 times 2 is 12. So 5 times 2 is 10. And then my equivalent of 3/4, 4 times 3 is 12. And so then 3 times 3 is 9. So then we add them together. So just write my 5 plus 10 twelfths plus 9 twelfths is 19 twelfths. And you can see that's going to be an improper fraction. Oh, I'm going to run out of space as well. That's okay. So 5, and this will be 19 twelfths as a mixed number, becomes 1 with remainder 7 out of 12. So then we just put the 5 and the 1 together. So that makes 6 7 twelfths. Okay. So that's how you deal with it if the two fractions in mixed numbers are different. So yeah, similar steps. Some people prefer this way. Some people prefer to just convert it to an improper fraction and then just add them together. Both ways will work. Now with subtraction, I've got a set of steps for this as well. Um, there's a slight variation, and I'll show you what I mean. So when we're looking at simplifying fractions using this other method 2, similar to before, you still look at the whole numbers and you still look at the fractions. So with this one, we subtract them. So we've got 5 minus 3 this time, and then plus 2/3 minus a quarter. So you're just subtracting them this time. So 5 minus 3 is 2. We've got two different denominators, so we need to make lowest common denominator. So in this case, it's going to be 12. Okay, so make them both 12. So the equivalent of 2/3 to 12, so times that by 4. So 2 4s are 8. 4 times 3 is 12. So we do the same to the top. So that's going to be 8/12 minus 3/12. Okay, so I'll just keep them in the bracket. So that will become 2 and 8/12 minus 3/12, which is 5/12. Okay, so that works really well because 2/3 is actually bigger than a quarter. Now we do something slightly different when the two fractions are different sizes. So what I mean by that, so in this second one, which I've deliberately rigged obviously, 8 1/5 minus 4 3/4. 1/5 is actually smaller than 3/4. So when I write it out, my second line, I put my whole numbers together like I did before. 8 minus 4, okay, plus, excuse me, 1/5 minus 3/4. Now, stop there, because 1/5 minus 3/4 means you're heading into negative territory and it's really confusing. So we don't do that way. We do something called regrouping. So what does that mean? What we do is we want to make our 1/5 into a fraction that is bigger than 3/4. So what we do is we borrow, or we regroup, it's the other word, from from 8. So what we do is we take our 8 and we essentially borrow, or we change it to a 7. So what we're actually doing is we're taking 5/5 and we're adding it on to 1/5, because that's like the equivalent of 1. So we change our 1 to 6. So it's going to be 7 and 6/5, which is the same as 8 and 1/5. So I'll say it again. So I'll rub it out and I'll actually do it again just to reinforce it. So 1/5, do it for color. 1/5 is smaller than 3/4. So we have to regroup them. So I take from the 8, or I borrow, and I'll change that to a 7, and then essentially I add on the equivalent of 1. So the other way to look at it is, I've got the denominator, which is out of 5, add 5 on. That will make that into 6. So that will become 7 and 6/5 minus 4 3/4. Okay, so you have to do it when the first fraction is smaller than the second fraction. Otherwise, it won't work out. You can't do this method. If you don't like this method, this is when you go back to the other method and you go, this is too much work. But let's keep going, because I'll show you how this will work out. So 7 and 6/5 minus 4 3/4. Now that my first fraction in my mixed number is bigger than the fraction in my second mixed number, I can now do the adding the whole numbers and adding the fractions together. Subtracting them. So 7 minus 4, okay, plus 6/5 minus 3/4, okay, and then you go 7 minus 4, which is 3, plus do the common denominator thing. So 5 and 4. So we've got multiples of 4, 4, 8, 12, 16, 20. And 5 is going to be 5, 10, 15, 20. Oops. So 20 is my lowest common denominator. Minus 20. All right, so then let's write the equivalent fractions. So 6/5 times 4. So 6 times 4 is 24. And then we need to multiply this by 5. So 4 times 5 is 20. 3 times 5 is 15. Okay, so then that will become 3. And then 24 twentieths minus 15 twentieths is going to be 9 twentieths. So it'll be 3 and 9 twentieths. So this is this other way of doing it. If you, and I say you want to know how to do both ways, and then you can decide each time which way might suit you. I think this second method works really well for fractions when you're adding them. Pretty straightforward. With subtraction though, you do have to look at the fractions within the mixed number. If it's smaller, then you make a call on which method you want to use, because it does get a bit complicated when you look at it that way. Anyway, I'm going to upload this video, so feel free to watch it again, because particularly this particular example here might need another rewatch. And yeah, today I'd like you to attempt as many questions as you can trying this method, and you can play around with it. Try this method, try the other method, see which one you prefer. On a test, you can actually use whichever method you prefer. And if you're, and I would say you want to try and be able to use both methods if you can. Okay, so see how you go. Good luck today, and hopefully I'll see you next week. Thanks.